Okay, I'm going to teach you in this lesson about inequalities. Okay, so far what we've been doing, all of our algebra that we've been learning has been equalities, equations, meaning they're equal, right? So both sides are equal. Well, in inequality, we're going to solve it the same way, but both sides are not equal. So there's 4 different terms that will come up with inequalities, and I want you to be able to recognize these symbols because they're going to be really important on the test. This is the word I'm saying, inequality, meaning not equal, all right? So the 4 possibilities would be that sign right there, okay? And that means greater than. I'm going to write the words, but I'm going to erase them in a minute, just so that we have room on the board. I'm saying greater than, okay? Whatever I've got, it's greater than that, is what we're saying. This sign here is less than. Now, here's the really important thing. Just realize the big opening is towards the bigger number. Think of it like Pac-Man, okay? So like, let's suppose I had 8 and 4. Well, which one is greater? The 8. So the bigger number, the opening is towards a bigger number. Think here, I made him Pac-Man, right? Okay? Well, suppose I'd written it the other way. If I had 4 here and 8 here, the 8 is larger, so the opening is toward the 8. Okay? Just imagine a little Pac-Man. He wants to eat it. So don't get hung up on whether you can remember whether it's less than or greater than. You just need to remember that the opening goes towards the greater value, okay? The other 2 symbols that can show up build off of these. It's greater than or equal to. There's a line underneath it, just like the bottom line of an or equal to. Greater than or equal to. That means, like, look at this. This is a strange idea, but literally, 4 is greater than or equal to 4, right? Because 4 equals 4. If I had this, that's not true, because 4 is not greater than 4, but it is or equal to, okay? And then the same thing can happen with the less than. You might have the line underneath there, it means less than or equal to. It's as though this, if I had x is less than or equal to 3, I am saying that x could be 3, okay? If I was on the number line with it. 2, 3. If I just had x is less than 3, then I'm saying I go to 3 and I say it's anything less than, it's anything to the left of it. But if I say or equal to, I actually would color that dot in to say it could be 3. So if I try 3, it should satisfy that equation, or anything less than 3. So those are your 4 terms for this. I'm just going to erase this so I have more room, but I want you to, store those away with the primary idea that, again, the opening faces, the larger opening faces the greater value, okay? Now, when we're solving algebra problems, we know these steps, that you solve both sides by combining like terms, you isolate your variable term, meaning you get it by itself, and you solve by doing the opposite. That third step is almost always dividing, okay, unless we're involved in exponents. But those 3 steps are going to stay put with us on inequalities. There's just going to be one additional thing, and we'll get to that. So, if I had 3x is less than 9, okay? Solve both sides. Nothing I can do. Isolate my variable. It's actually already done. So I'd be at step 3. I want to solve by doing the opposite. Well, this is 3 times x. So the opposite would be to divide. X would be less than 3. Exact same steps, right? Suppose I have, Let's change it a little. Well, let's even do this. Let's say plus 6, okay? 3x is less than 9 plus 6. Solve both sides. Well, I can do something actually, can't I? 9 plus 6 is 15. Isolate my variable, it's already done. So solve by doing the opposite. Opposite of multiply is divide. And remember this is 3 divided by 3 is 1, is less than 15 divided by 3 is 5. Okay, so we know those steps. They still apply the exact same, even if this was less than or equal to, that doesn't change it. I do all the same steps. Here's where the uniqueness comes in sometimes with inequalities. It's if, well, let me just show it to you. If I had negative 4x is less than 16. Well, what do I want to divide by to get to 1x? I want to divide by negative 4. Not positive 4, because then I'd have a negative x. I don't want negative x. Negative 4. So anything you do to one side, remember our principle, anything you do to one side, you must do to the other. So negative 4 divided by negative 4 is positive 1. So I've got my x. 16 divided by negative 4, again, you'll have your calculator. So confirm it's negative 4. Now here's the uniqueness. I divided both sides by a negative, so I reverse my sign. That's the rule I have down here. With inequalities, if you multiply or divide across the sign, so both sides, by a negative number, you reverse or flip the sign. Here's why. Suppose I have, let's say, I don't want to use 7, that looks like an equals or a greater than sign too much. Let's say 8 is greater than 5. I hope you agree with that, right? Its opening is towards the larger number, right? Well, let's suppose I make them negative. Negative 8 and negative 5. Notice my sign reverses because negative 8 is actually less than negative 5. Think of your bank account. You know, you don't want to see negative, but would you rather see that you're negative $8 or you're negative 5? Negative 5, right? So when you go to the negative sign, when we go to the negative numbers, the value actually reverses. The number that quote unquote looks bigger, looks larger, when we're in the negatives, is the smaller number, right? It's further to the left on the number line, which we know that means is of lesser value. So that is why you have to flip the sign. Now, you don't have to understand that, you just have to do it. Okay, I'm telling you that's why it works. It isn't magic, it's math. It actually makes sense. But the bottom line is you just have to do it. Let's try another one. Let's suppose I have negative 3x plus, well, I don't want to use, I'm sorry, I keep trying to use 7s. I don't want to use 7s because they'll confuse with the sign. Is greater than, let's go greater than or equal to, right? Let's say 14. Okay? Solve both sides, nothing I can do. Isolate my variable. What do I need to do to get my x turned by itself? This 8 needs to move. So remember, we always do the opposite, because that's how I get it moved. So negative 3x, because 8 minus 8 is 0, that's what I wanted, is greater than or equal to 14 minus 8, use your calculator, is 6. Last step, do the opposite, divide by negative 3, divide by negative 3, that becomes 1, so x is greater than or equal to 6, oopsie, that's not what I want to do, I apologize, 6 divided by negative 3 is negative 2, so because I divided both sides by a negative sign, I must reverse the sign. I guarantee that will be one of your answer choices, okay? Because they're testing to see, do you know to reverse the sign or not? So that's why typically I saw both sides and then I pay attention to my sign. Because you saw how when I just took off with it for a split second there, I just wrote it and didn't pay attention to it. I'll saw both sides and then I think, okay, wait, I divided by a negative on both sides, so I need to reverse the sign. Let me show you where this applies and where it doesn't. If I had, suppose I just had 7x is greater than negative 21. Well, I'm going to divide both sides by 7. So I'd have x here, negative 21 divided by 7 is negative 3. But notice this, my sign stays the same. This was negative, but I did not divide both sides by negative. So I wouldn't flip the sign, okay? And all your rules are going to apply. So if I had the problem negative 5x minus 9 is less than or equal to, let's say even negative 11. All right, solve both sides. There's nothing I can do. Isolate my variable term. So what do I need to move? It's 9. So I do the opposite. I'm going to add it. Got to do it to both sides then. Oh, that wasn't what I wanted to do. I'm going to switch this, guys. Let's say this is positive 9, and you'll see why I want to do this in a minute. Let's say this is positive 9, okay? So what do I want to do? I want to subtract it. Subtract it from both sides. Negative 5x. Okay, negative 11 minus 9. Use your calculator. Negative 20, okay? Got my less than or equal to there. Last step, solve by doing the opposite and divide by negative 5. Divide by negative 5. Divide by negative 5. Negative 5 divided by negative 5. My x. Negative 20 divided by negative 5. A negative divided by negative is a positive. But I divided both sides by a negative, so I reverse the sign. Okay? So I'm going to follow all my algebra rules, and I'm going to flip the sign if I divide both sides by a negative. Everything else stays the same. A negative divided by a negative is a positive. All those kinds of things remain the same. And I'll say again, you'll have your calculator. So let me just do 2 more simple ones just to try and reiterate this rule. If I have negative 6 is greater than 24, divide both sides by a negative. So I have x, 24 divided by negative 6 is negative 4. Because I divided by a negative, I reverse the sign. If I had negative 6x is greater than negative 24, I can divide both sides by negative 6. I've got x. Negative 24 divided by negative 6 is a positive 4. But I divided both sides by a negative, so I'm still going to reverse my sign. Let me show you one more little part of this. Suppose it was 6x is greater than, let's say, negative 24. 6x is greater than negative 24. Divide by 6, divide by 6, x, negative 24 divided by 6 is negative 4, but I did not divide by a negative, so I do not reverse my sign. So look closely at these 3. Both of these times, because I divided by a negative, I had to reverse my sign. Divided by a negative, I had to reverse my sign. This time, yes, I have negative 4, but I did not divide both sides by a negative number, so I do not reverse my sign. Otherwise, stay with your rules and then just add that to it.